All right, welcome back, everybody, to second section of the web application lecture. So we talked a little bit about cookies at the previous one, but we're also going to talk about some of the pieces of the web application, puzzle, as it were. Um, one of the big things parts of web applications is the login or the authentication process. So um, basically, a login or the authentication process, it's the component that's kind of presented to you as the user to provide a username and password for authentication, and later for authorization. So technology wise, there are different ways to authenticate a user, which can include anonymous authentication, which basically boils down to all visitors or guests to a site are using the exact same account to access resources. Um, there's no login dialogues or prompts or provided. You're just clicking to the website. You're an anonymous authentication. You're a guest user, and you're just kind of going through the web page. Then you have basic authentication. So this sends all authentication information in plain text, or it's base 64 encoded. So it's usually something that's over HTTP on port 80. So basically, we showed this in Wireshark with FTP, Telnet, HTTP. Everything is transmitted in clear text, or it's using base 64 encoding. Then there's digest authentication, and this is basically it's passing a hash for authenticating a particular user. Um, then there's the Windows authentication. This is usually used for Microsoft applications, and it uses the Windows authentication technology to kind of perform the authentication process. Um, that's typically what it uses. There are a couple other ones that there's stuff like using a certificate. Um, there's certificate mapping. Some of the other kind of minor ones there. Um, and some of the things that I just kind of want to talk about before we start jumping into vulnerabilities. There's so many different pieces to the puzzle when it comes to web applications. There's uh, data storage, there's the web server, there's the logic components, and there's so many different pieces, and there's so many different vulnerabilities that can happen with each piece of the puzzle as you're kind of moving through the application. And we just want to kind of talk about a few of those risks. What you as a administrator of a network or an administrator of an application or even a developer that you need to be mindful of as you're kind of working on a web application, and how you can try to better secure it. So we talked about what web applications are. We've talked about how they can be stored up in the cloud. We've talked about some of the different pieces, the people that are involved in designing web applications. So we kind of want to talk about just some of the different vulnerabilities that kind of go along with it. So there's always constantly just a flood of different web applications, vulnerabilities, web applications. Because websites and servers, they're the side of the company that most people usually encounter. You're not going to see too often where you have a customer or a client or just a regular user that's going to see the internal network. We talked about the DMZ. The web application is the face of the company. Um, this is the main part that you're going to encounter, that you're going to try, that most attackers are going to try to take down. Um, and it can be devastating to a company. So let's kind of look at some of these exploits here real quick. So let's look at the first one here. So the first problem when it comes to web applications is you're looking at a flawed web design. And a pretty common way that attackers exploit web applications is actually the code itself. So usually, if you right click on a web page and you go to view source code, you're going to see the actual coding of the web application, and a lot of times developers will leave comments and hidden tags in the web page, and this can give a lot of information to an attacker. And although that most of the time these tags or information, they're not intended to be displayed in a web browser. They can be viewed by just simply viewing the source code. And when it comes to clients, when we're doing web application testing, that's one of the first things I go through. I start going through their web application as an anonymous, just a regular user, and I start looking at the source code pages, looking for comments, looking for just to kind of get a better idea of what's going on with that particular web application. Sometimes you'll get the specific versions of software that's loaded, so you can start googling vulnerabilities and exploits for those particular types of web applications. The next one is buffer overflows. So this is a very common vulnerability in web servers and in a lot of software. So a buffer overflow is basically when an application, a process, a program, it attempts to put like more data in a buffer than it was designed to hold. So in practice, what a buffer is, it's designed to kind of hold a specific amount of data and no more than that, just that amount of data. So in the case of a buffer overflow, a programmer, either through just being lazy or whatever, creates a buffer in the code, but doesn't put a restriction on it. So it doesn't say, okay, well, the buffer can only be this size. So the data has to go somewhere, into the buffer right beside of it if it's too large. So when that data, it kind of spills over or overflows into the buffers that it was not intended to go into, the result can be corruption or data overwritten. And if this occurs, data loss, the integrity of the data can be, taken advantage of. So in a lot of extreme cases, buffer overwriting can lead to anything from a loss of system integrity to the disclosure of information. And a lot of times what I will do is if there is a buffer overflow, you can actually create a payload. An attacker can take a payload and actually put that payload code into that buffer and causing it to execute. We talked about denial of service attacks. Basically wreaking havoc with a company. If it's vulnerable to a denial of service, it can be carried out against a web server just like it can, other servers. Resources consumed and slowing down performance, or it's more of an annoyance than anything else. Distributed denial of service, we talked about this already. Again, this is another annoyance. It's more than anything else. It kind of accomplishes the same goal as a regular denial of service. It consumes the resources that can be used for people that are actually trying to access the website legitimately. But the main difference is the scale. So a distributed denial of service uses a lot more systems to do the attack. Crushing a web application against all the different requests at one time. There's things like ping flooding attack. You basically, a computer sends a ping to another system with the kind of the intention of uncovering information about the system. And this system can be kind of scaled up so that packets being sent to a target basically cause it to go offline or slow down. So this can be easily performed through a lot of different tools that are out there. So that's another type of attack. There's the Smurf attack. It's very similar to a ping attack. A little bit of a difference. So in a Smurf attack, a ping command is sent to a network where it's amplified and forwarded onto a target. So that one single ping now becomes like this huge storm of traffic after it's amplified. Then there's like what's called SYN flooding. We talked about the three-way handshake. So the SYN flood is basically the equivalent of sending a letter that requires a receipt. So the return address is usually fictitious. So if a return receipt is required and the return address is fake, it's bogus, then the receipt's going to go nowhere, and a system is going to just sit there waiting for confirmation, out there and nowhere in just limbo for a period of time. So an attacker will send these types of requests to a system, and it can use up all the connections on the system so that nothing else can get through. So again, it's almost like a denial of service. All right, so some additional security problems with web applications, and I don't want to say so much it is a security problem, but this is uh, additional ways that an attacker can try to get information, and try to get a good idea of how the web application works, how your network works. Banner information. Attackers are always using banner information to kind of footprint. What the corporation looks like. Trying to gather information by doing like a quick banner grab. They'll go out there and do something like try to use a telnet tool or putty or a lot of different tools out there. Netcat. They try to grab that banner, kind of see what kind of information, what kind of what version of PHP or what version of Apache's running, or whatever. You're trying to get as much information as they can. So this is usually they're trying to grab a header file to kind of obtain that, and it reveals a lot of information. So to try to restrict that banner information, or a lot of people will try to actually just go in there and change the banner to something absolutely ridiculous. I knew one particular client. Instead of revealing information about his, internal network, he would put something up there like Nintendo or something crazy, and it gives like just insane information. So just altering the banner. A lot of error messages can really reveal a lot of information about web applications, specifically versions of Apache or Tomcat or whatever. And so if there are vulnerabilities associated with a particular version of software running on that web server, then it can give that information away. So it's kind of reveals those types of default errors need to be changed to something a little bit more general, so that you don't give that information away. A lot of types of attacks, come in the form of like vandalizing web servers. I think one of the most common is basically defacement. So defacing a website it can be aggressive or it can be very subtle, depending on what the attacker's trying to do. In any case, the goals are the same: to try to embarrass the company, to make a statement you're a hacktivist, or just to be a nuisance. To kind of deface the website. It's possible to kind of use a different number of methods. Depending on the attacker's skill level or capabilities, or even the opportunities that are available. That's one of the additional security problems. So misconfigurations are a very common security problem. Kind of get this one out. Web servers and applications are very complex. So no matter whatever way you view them, it's very easy for even the inexperienced but well-intentioned administrator to misconfigure or just kind of miss a setting that enables an attack. And I think this is one of the most popular ones that I use on a daily basis. So kind of prevent misconfiguration from becoming a problem. Administrators really need to make sure that the role of a server is correctly defined. There's a plan, and to evaluate the configuration to make sure that it will, it's going to, provide the necessary protection. Reviewing the security best practices through the Center for Internet Security. Microsoft's got some good steps in there, and the biggest one is using vulnerability scanners against things like Nessus, Qualys. Nest Pros, things like that. Another very common problem is input validation. So input validation is basically it's used to verify information as it's entered in. And so like a user's entering data in a form or something like that. And so if there are not restrictions placed on what a user can enter, this can become a problem for administrators. So when that data is taken in, there's no restrictions in the coding, you know, intentional or unintentional, this can lead to problems. So validating input is so important, to try to keep, database corruption down, manipulation, buffer overflows, inconsistent data, that kind of thing. Another really popular one is cross-site scripting. So cross-site scripting, it relies on a variation of input validation attacks, but the target is different because the goal is to kind of go after the user instead of the application of the data. So an example of cross-site scripting uses scripting methods to kind of execute a Trojan with the target's web browser. People can usually do this through the use of like scripting languages like JavaScript or VBScript or but an attacker can basically look for ways to kind of inject malicious code into web pages to kind of gain more information. Anything ranging from session information on the browser or elevated access, or if you want to do some additional looking into cross-site scripting, I highly recommend it. But we're not really going to. I just wanted to kind of bring that one again. Most of this class is about introducing you to concept, going over a brief explanation, helping you to understand bits and pieces, and then you going after those pieces as you move along through your careers. All right. So another really common problem is like redirects and forwards. So, and if they are invalidated. So to kind of think about this type of attack, imagine a site that has a redirect page that takes a URL and for a particular website, and you cause whatever your targetsite.com is, and an attacker is able to redirect it to a malicious website. So when the user sees the link, they'll see whatever their favorite website is, like favorite.com, blah, 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 blah. So the user thinks that, it's a trusted website, to click on it, but in reality, the attacker has altered the redirect to his website that looks very similar to, the user's favorite website. A lot of times you'll see this in social engineering. You'll get an email that'll say, hey, there's been a compromise of, your, website, your PayPal account, your bank account, whatever, and it will show in the email bankofamerica.com or paypal.com, but you click on that and it'll actually redirect you to a malicious website where you'll log in with their credentials, and then your credentials are stolen by an attacker, then used to log into the website. So this is a very common problem. A lot of web applications, they require some type of authentication or login process, and because of this, it's really essential to be handled safely and securely. And you got to really take care that that the incorrect or improper entry of information doesn't really reveal any information to the attacker. So when I say this, think about it like this. Okay, so you go to a website and you try to log in and you type in a username. It's, the right username, but it's the wrong password. So you'll get an error message that'll say, this is an invalid password. So it's telling you that you got a correct username. You just have an incorrect password. So it's giving you information here. Or you're putting in, usually a better way to do it is to say, either the username or password that you have entered is incorrect. I'm sure you've seen this on several different websites. That is a better, more secure way, because if someone at least knows that they got the username correct, they have half the puzzle right there. and they can do stuff like password attacks, on that particular username, trying to gain access, to that particular website. So that, that's definitely something that you have to take care of. There's stuff like scripting errors. That's another really weakness. So like a common gateway interface like ASP.NET, Java Server Pages. They're commonly in use in a lot of web applications, and they kind of have their own issues to go along with it. So vulnerabilities like the lack of input validation scripts, can be a liability. So a really smart attacker can use a number of different methods to kind of cause grief of the administrator of web application. So that, again, that's just another one of those issues. Again, I'm not going to ask you to describe each one of these, but I may ask you to name some, issues or problems with some web applications. Name 3 common security problems with web applications. Session management, that's always a big one. A session basically represents that connection between the client and the server. So the session information, that's maintained between the client, it's important, and it can give an attacker access to confidential information, if it is compromised. So ideally, a session will have a unique identifier. It'll have encryption. It'll other things that are signed every single time a new connection between the client and the service created. So after the session is exited and closed or not needed, so this information needs to be discarded and not used again. Some of those log out features need to be in place. They need to be on the web page. There need to be session IDs that are easily predictable or guessed are always a problem. So if there's you can see a common way that session IDs are created, then maybe an attacker is able to capture some of those session IDs and predict them, and maybe bypass some security features, using someone else's session ID to take over a session of a legitimate customer. So another really common problem is encryption weaknesses. So when it comes to web applications, there's a lot of encryption that we talked about at the beginning of the semester involved when it comes to web applications. And I'm not going to beat a dead horse about this because we did talk about it quite a bit. But using something like weak ciphers are basically weak ciphers are basically encoding algorithms, and they use like short key. If they use short keys or are really poorly designed and implemented, then this can definitely be a problem, because if you're using a weak algorithm to encrypt the data, then it's going to be more easily compromised. So it's important. Don't ever underestimate the value of the data being processed and transmitted over a web application, and how to protect it. So weak ciphers is definitely a problem. Using stuff like software that's vulnerable. So like OpenSSL. These are tools and kind of resources that are available in assessing vulnerable software when it comes to web applications. OWASP guide to common cryptographic flaws. You can find that at the website there. The Nessus vulnerability scanner is one that's pretty popular. There's others like paid that are Qualys. There's Nexpros, like I mentioned before, trying to find that vulnerable software and try to keep that stuff patched and up to date. So there's also things like directory traversal. And so directory traversal is basically an attack, to kind of move outside, a web server directory into the other parts of the system. So if there's not access controls in place, they're used to kind of indicate which users and groups are allowed to access certain files. And if these things aren't in place, then definitely trying to move through directory traversal is a possibility. And even the root directory can be accessed. If every person can access the root directory, then they can get a shell or a command shell on that particular box, and take over the box. So that's definitely something to be careful of and be aware of. When it comes to a lot of this stuff, it's important when you have these web applications is to test them. And there's lots of tools out there that you can use, like Burp Suite, and there's proxies and all kinds of different tools out there to test web applications, and you know and again, this has not been a lecture that is deep down into web applications. I just want to kind of give you an introduction of what web applications are, some basic risks and basic problems, and the basic layout of how web applications work. So a lot of these vulnerabilities, they really need to be considered when you're setting up a web application, whether you're a developer or an administrator. And a web application, is presented through their standard web browser or a client application, like such as webmail, streaming video. So they're so popular and they're so powerful on so many different fronts. Especially over the past few years, and they've become such huge targets for attackers. So that's the reason I really wanted to cover these. At least skim over them. To talk about them at least, because attackers can easily perform actions like banner grabs, upload bombs, they fingerprint web applications, try to gain access to information, or they can even if they can get a shell on the box, they can penetrate even deeper into the organization. So securing web applications really is a very, very important task when it comes to IT security. But again, as far as the quiz is concerned, we're just going to kind of touch upon these, but didn't really dig too deep. If you do have any questions, please feel free to reach out to me, and have a nice day.